Naive string matching algorithm. You are going to compare only one character at a time. That is the underlying logic of the naive string matching algorithm. If you use naive string matching to match this example, you can't compare 3 at a time, because A, B, A are 3 characters no. If you use naive string matching algorithm, always you have to compare 1. It means that you have to start from the left-hand side boundary. At a time you are going to compare only one character, so A and A. You don't compare A, B, A. A and A is a valid matching. If that comparison is valid, only you go for the next one. In case if this is invalid like A and B, you know that if it is A and B, it is invalid. So do I want to go for the next one? No, because we know that with that placement you don't have any comparison. Shift means the placement. Placement mean you know that it is starting from the left-hand side boundary. This is shift equal to 0 placement. Now we are in shift is equal to 0. There you are going to compare one character at a time, A and A. It is fine, it is valid. If it is valid, you go for the next one. B and B. Again valid. That is also valid. You go for the next one. A and B, that is invalid. It means that here in this shift, how many comparisons I did? 2 valid and 1 invalid. Totally that is 3. In this shift you can't get the pattern. So that you can't get the pattern means, remember altogether, this is we called as invalid shift. Then what you want to do is, you have to move for the next placement, or you have to move for S1. How you are going to do is, move your entire pattern, one character to the right-hand side, and do the comparisons. Here is the final outcome. Total number of shifts equals 0 to 5. It means actually 6. There is a formula for find the number of shifts. From applying that formula, without drawing, you can say how many shifts will be there. The number of characters inside the text is 8. Number of characters inside the pattern is 3. Total number of shifts is 6. You know that the best case is the place where the total running has to be the very lowest. If you think about an algorithm, the best case of the algorithm means an algorithm is running very quickly. Algorithm is running very quickly means time complexity Tn is less. How you are going to match this condition into the naive string matching algorithm. You know that naive string matching algorithm is going with the number of comparisons. If you have less number of comparisons, the time also less. Number of comparisons should be less means what is the minimum number of comparisons that we can have? It should be 1. Least number of comparisons in all the shifts should be 1. In order to get that one as always 1, what kind of a pattern do I want to have inside the pattern? It means first character, it should be stop. How to stop from the first character? It has to be an invalid character like C. Other 2 characters may be there or maybe not in the text. We don't care. Total number of comparisons or total number of shifts equal to 6. Naive string matching algorithm best case is happening when the first character of the pattern is not existing with the text. Time complexity equal to big O(n) minus m plus 1. Worst case. Worst case means you are getting lot of time. In order to get Tn is too large, number of comparisons should be maximum. Maximum number of comparisons should be done. In order to get maximum number of comparisons, what kind of text and a pattern do I want to have? It should be this kind of text and a pattern. Total number of comparisons equal to 18. 18 means 3 multiplied by 6. 3 means number of characters inside the pattern, which is m. 6 means number of shifts, which is n minus m plus 1. Then we can write total number of comparisons as m times the quantity n minus m plus 1. Then worst case time complexity is equal to big O(m) multiplied by the difference of n and m, increased by 1. That's the end of our first lesson. Thank you.